Yeah, this is the circuit for line follower robot which we are doing in virtual environment, that is in Proteus software. This is the Arduino Uno board which I have selected from the components mode and pick, added to the bucket list and selected placed here. And this is the L293 motor driver, and these are the two motors, and this is the left side, right side. Assume this as right side wheels, and this is as left side wheel, and this is motor 1 and this is motor 2. Just remember this has motor 1 and this has motor 2, and this is L293 motor driver. Due to non-availability of IR sensor in Proteus software, we are using buttons to give input which IR sensor does. IR sensor gives only zeros and ones. It actually senses between the lighter and darker surface. So buttons also do the same things, which if you press the buttons, it will send the one. In the same thing, if the IR sensor zeros and one sends. So if the obstacle is there, so it will send 0. This is the left side sensor, and this assume this has pin number 7 as left side sensor and pin number 6 as right side sensor, which are connected to the pin number 6 and 7 respectively. So this is the button 1 and this is the button 2, which acts as left side sensor, and this button acts as right side sensor. If both the buttons are low, which means there is an obstacle in the both sides. That means right side also obstacle and left side also obstacle. So it has to move. It has to wait for some minutes for the user decision. If there is no obstacle in the left side and there is an obstacle in the right side, that means it will sending an 0. So for in that time, it has to move in left wise direction. For left wise direction, both the motors has to rotate in anti-clockwise direction. If there is an obstacle in right side, that means button is on. There is no obstacle in the obstacle means let's start from the forward direction. So one means actually IR sensor senses between the lightest and darker surface, which I have explained in the previous video. So there is one sending IR sensor sending one means there is no obstacle in the front side or in the right side or left side. There is no obstacle. All the rays are reflecting back, and it will be sending one symbol to the pin number 7, and pin right side left side sensor sending 1. That means no obstacle. Right side sensor sending 1. There is no obstacle. For this motor has to right side motor has to rotate in clockwise direction, and left side motor has to rotate in anti-clockwise direction. By that time, it will move in forward direction. If this is the left side sensor, if there is an obstacle on the left side, it has to move in left-wise direction. That means this IR sensor sending 0. There is no rays reflected back from the surface, so it has to move in left-wise direction. So it will be sending 0. In that time, both the motor has to rotate in anti-clockwise direction. If both the motors rotate in anti-clockwise direction, then it will move in left direction. The line follower robot will move in left-wise direction. If in the case left side sensor is 1, there is no obstacle in the left side and there is an obstacle in the right side, it has to move in right-wise direction. That means there is an obstacle. It has to move in right-wise direction. So both the motor has to rotate in anti-clockwise direction. By this time, motor will move in forward direction. If you need any further clarification, go through the previous videos. I have explained that how the wheels of the car rotates when it's moving forward and moving right-wise direction, and when it is moving in left-wise direction. So go through that and you will have a clear picture. So right side sensor sending 0 means there is an obstacle in the right side, then it has to move in right-wise direction. At that time, both the motors have to rotate in clockwise direction. If both the motors rotate in clockwise direction, then it will move in right-wise direction. If there is an obstacle in the both side, that means left side, there is an obstacle, and right side also there is an obstacle. So the line follower robot has to wait for some minutes for the user for the user using it for the decision of that. So this is the line follower, simple line follower, line follower which we are going to do in Proteus. For this we need for this programming part has to be done. So in the void setup part, we are declaring these pins as output pins. For output pins we are using for the output pins that we are using in Arduino, we need to declare them as output. By default, every pin in Arduino Uno acts as input pins. There is no need to declare input pins. So we are not declaring pin number 6 and pin number 7 as input pins. We are giving input to the pin number 6 and pin number 7. So we are not giving declaring that in void setup part. So by default, it will act as an input pins. If we want to use the pins as output, we need to declare that we have done here pin mode pin number 8 comma output, pin number 9 comma output, pin number 10 comma output, pin number 11 comma out. So pin up to pin number 13 we are using those pins as output pins, so we declared them as an output pins. In void loop we have to write the code which has to done in loop. So by the name loop indicates the code will again repeat again and again itself until it gets over. So in looping condition we need to declare integer. We are for this pin number 6 and pin number 7, we are getting a data from this IR sensor, left side sensor and right side sensor. So we need to declare one variable that is called int. ls is the name of the variable, and then digital read. It has to read digitally, means it will read only zeros and ones. So it has to read digitally. So pin number 7, it will read digitally, whether it may be sending zeros or ones. Okay, this is the pin number 7. We are reading the pin number 7, whether it is sending zeros or 1. Actually, the IR sensor sends zeros and ones value only. So digital pin number 7. We are reading from the digital pin number 7 and storing into the variable ls. Similarly, for the right side sensor, we are reading digitally from the input pin number 6. If the both the condition, as I explained in this Proteus part, if these both the buttons are on, means sending one values, and left side sensor is 1 and right side sensor is 1, there is no obstacle in the left side as well as in the right side. So motor has to move in forward direction, right? There is no obstacle in the left side as well as in the right side, so it has to move in a forward direction. And this is the functions we are going to write this function part later. For just we are applying if condition. If this condition becomes true, it will execute this forward function. So if there is no obstacle in the left side and there is an obstacle in the right side, so for this, just a moment, if the mode, yeah, if you assume this as line follower robot, it has to follow this line. There is an IR sensor in the right side as well as in the left side, one transmitter and then one receiver, in the right side there is an obstacle. It will, if it reaches this part, there is an obstacle in the this part. So for right side sensor senses, which means it sends some radiation. No radiation will reflect back to this sensor. That means receiver end does not senses any of the radiation, so no voltage inducer, so it will send 0. So 0 if it moves in right-wise direction. If this moves in right-wise direction, left side sensor, right-wise direction means left side sensor will become this and right side sensor will be placed like this, and this is the line follower and it will move in right-wise direction. This is the right-wise direction. Okay. Similarly, if there is an obstacle in the left side and there is no obstacle in the right side, it has to move in left direction. If there is an obstacle in the both the sides, it has to wait for some minutes, wait it will stop. It means we are switching off the both the motors using this condition part. So for forward path, pin number 30, motor 1 has to rotate in clockwise direction, so that we have already discussed for rotating in clockwise direction what are all the conditions we need to give this motor. So pin number 13 should be high, pin number 12 should be low. See here, pin number 13 means which is shorted with which is connected to input 1, and this pin high means it will comes 1 year, and it will 0 year, so it will rotate in clockwise direction. Similarly, this motor has to rotate in anti-clockwise direction. For that, pin number 9 should be 0, pin number 8 should be 1, so it will rotate in anti-clockwise direction. Similarly, pin number 9 should be low, pin number 8 should be high. That we have done. So for left part, both the motor has to rotate in anti-clockwise direction. So motor 2 is already rotating in anti-clockwise direction, same condition. So we need to change one part is pin number 13 high here. We need to lower the pin number 13, and we need to give high to the pin number 12, which is pin number 12 is lower. We are reversing the direction of motor 1, which previously rotating in clockwise direction. It has to rotate in anti-clockwise direction. So both the motors are rotating in anti-clockwise direction, then it will move in left-wise direction. Similarly, both the motor has to rotate in a clockwise direction. So this is the condition for forward direction. Right motor has to rotate in clockwise direction. This is the condition for clockwise direction. And motor 2 has to rotate in clockwise direction. So we discussed this. For weight, all the pins should be low. So every pin should be low. I forgot to tell one thing. This is the speed of the motor. We are declaring the speed of the motor in which speed motor has to rotate. So this 255 is the maximum speed of the maximum speed which we are able to give. That means this is the PWM pin which we are using, pin number 10. It has the range from 0 to 256, that is 8-bit configuration. So it can vary up to 0 to 255. So 255 is the maximum speed. We have given a maximum speed to the motors. That's it. Then compile this code. Okay, done. Compilation, there is no error. So copy the X file link, which is from last 4th line. Just double click on the Arduino board. It will pop up this. In the program file, paste the X file link. Okay. Then run. For both the inputs are high means one motor has to rotate in right motor has to rotate in clockwise direction, and left motor has to rotate in anti-clockwise direction. There is no obstacle. Both the ASMs are sending one means it has to move in forward direction. For forward direction, one has to rotate in clockwise direction, and the one has to rotate in anti-clockwise direction. So forward direction is true, it will move in forward direction. If the left side sensor is 0, right side sensor means 1, it has to move in left-wise direction. There is an obstacle in the left-wise direction, so both the motor has to rotate in anti-clockwise direction. If both the motor rotates in anti-clockwise direction, it moves in left direction. If left side sensor is 1 and right side sensor is 0, there is an obstacle in the right side. It has to move in right-wise direction. For right-wise direction, both the motor has to rotate in clockwise direction. So if both the motors rotate in clockwise direction, motor will line follower robot will move in right-wise direction. If there is an obstacle in the both the direction, motor has to wait. It will stop rotating. It will stop moving in any direction. Ultimately, motor stops and user will go and changes the direction, and it will move. This is the line follower in Proteus software. Thank you.